Hi guys, and welcome to this video today, which is the second video on our series of least squares regression. Okay, in my previous video we looked at the least squares regression and the idea of residuals, and we looked at all of the theory that actually underpinned it, but believe it or not, we didn't do any examples. I know I started off with some sort of, idea of VCAR questions at the end, and I went, oh look, and I said, by the end of this series, we'll be able to answer those questions, and I will go back to them. But this lesson, we're actually going to do some examples by hand of how to determine the equation of the least squares line, and then use our CAS calculator. I mean, this is a CAS course. Why would we want to do all of this by hand? Now, if you haven't already done so, can you do me a favor and subscribe by clicking that doohickey in the corner? That just lets me know that you are watching, and obviously that would be great. Also, head over to maffsguru.com where you can register for free and download all of the resources that relate to this video, lesson notes, and all sorts of other stuff. So let's get a start. As I say, in the last lesson, we recapped, or rather I'm going to recap now, but the idea that our least squares regression line has the equation y equals a plus bx. Now, that just built basically on y equals mx plus c. All right, and for some reason in statistical analysis, we would normally write it in the form of y equals c plus mx. And then, yes, I know, because we're trying to trick you, we don't want to use the letters C and M. For some reason, we use A and B. But the idea behind what each of those letters stands for is exactly the same. This value here is my intercept of my y-axis, and this here is the slope of my line. And those two things you have to interpret in questions. And I've got some VCAR questions coming up showing you how that is done. Now we said, well, how do we find the value of A and B if we are just given a certain amount of information? So obviously, using our formula, we came up with the idea that we can find the values of B by using this formula, R times S underscore Y, or S subscript Y, divided by S subscript X. And what does that all stand for? Well, R we've already met, which is our Pearson's correlation coefficient. Sx is our standard deviation of X, and Sy is our standard deviation of Y. Now, with any luck, in an exam question, you will be given this information, and life will be good, all right? That's the value of A. We also need to find the value of B, which gave us y bar minus B times x bar. And what on earth is all this y bar and x bar? And once again, yes, it's given as x bar is the mean of the x values and y bar is the mean of the y values. Now, yeah, unfortunately, they could be evil and in fact ask you to work this stuff out by hand. And there are examples in previous videos that show you how to do that. As I said in my previous video, warning Will Robinson, we need to be very careful when using an answer from a previous part of the question in the next part of our question. And what we notice is we seem to work out a value of B here and then use it to help us find the value of A. Silly mistakes happen, but you have to try and do everything you can to mitigate against making those silly mistakes. Otherwise, sadly, your equation is going to be wrong, all right? Because you're reusing your value of B in that equation for A, just make sure that you check, and double check. When I taught this to my group, like a muppet that I am, I, for some stupid reason, got my S and X and SY the wrong way around in my equation, which obviously led to my equation being wrong. So there you go, word of warning, we can all make mistakes, and I make lots of them. Here we go. We are given a question by the Cambridge Further Maths Unit 3 and 4 textbook, and thank you very much to Cambridge for allowing me to use their examples. Greatly appreciated. You have some awesome examples. All right, so we're given that the heights and weights of 11 people have been recorded and the values of the following statistics have been written down. And yes, as you can see, in an exam, if you saw this, then hopefully you would be like, yes, this is awesome. Flip open your book, find the equations and substitute them in. All right, so use the formula to determine the equation of the least squares regression line and enable weight to be predicted from height. All right, weight to be predicted, that's awesome. We know exactly which one is now because this here is going to be my height and this will be my weight, because remember, when you're predicting, that goes on my response variable. So remember, we need the following formula. So we have y equals a plus bx. How do we find the value of b? Well, it tells me to take my value of r, which they give me as 0.8502, multiply that by sy, which gives me 7.594, and I'm going to divide that by my value of Sx, which is 7.444. Can't do that in my head, so I'm going to load up my CAS calculator. And so loading up my CAS calculator, the first thing I'm going to do is say, excuse me calculator, give me a nice little fraction that I can fill in. There we go, so 0.8502. We're going to multiply that by 7.594, and we are going to hit down and go divide that by 7.444 and hit enter, and I get 0. So that's equal to 0.868. Let's leave it to that. Does it say? Oh, it says correct to two significant figures. Okay, so two significant figures gives me 0.87. That's my value of B. Let's scroll up a little bit, and so I can get my value of A. My value of A is given by Y bar, which is 65.45, minus my value of B, which is 0.867 ... Now, I'm actually going to put the value on my calculator because I don't want to round values unless they're for final answers, whereas part B is my final answer there, or will be when I put it into my equation. I want to make sure that I use the actual value that they give me. My calculator lets me do that by dragging and pasting or whatever we need to do. So we're going to multiply that by my value of X bar, which is 173.3, and that's going to give me, all right, let's put that onto my calculator, 65.45 minus, now I'm going to use my ANS button, which is there, and I'm going to multiply that by 173.3 and hit enter, and out comes the value of minus 84.9 to, nope, that's not correct to two significant figures again, so that's going to be minus 85, correct to two significant figures. Having done that, I'm now going to substitute it into my equation, which gives me y is equal to, oh, now y, remember we've got this here because it wanted us to work out the least squares regression, so I have to use the weight and the height stuff. So weight can be predicted by giving me A, which is minus 85, plus B, 0.87, multiplied by what is on my x-axis, which is height. So there we go. So that there is my regression line, all right, or my least squares line. That would allow me to predict what's going on. But yes, as I said, wouldn't it be easier if life could do all of this for us? Now, obviously, there must be an easier way of doing this. Now, while we can't go back and check that our answer from the previous example is correct because they didn't give us the raw data, now it would appear we have some raw data. And I'm going to show you how to do this using your CAS calculator. So the first thing I'm going to do is fire up my CAS calculator. And I'm going to clear down what was there previously. Not that it's going to matter because I'm going to go into menu and statistics. And what you notice is I've already pre-populated my data. Now, the things to note here, ladies and gentlemen, is that I always label my columns. Height, weight, num, moths, whatever it is. I don't just leave it as list 1 and list 2 because it confuses the life out of me later when I have to do some more stuff like data transformations and what have you. It makes life so much easier if you just type. And to be honest with you guys, for the 6 seconds it's going to lose you in your life to do that, it may actually gain you 6 extra marks in your exams. All right, so there's my data. I'm just making sure it's all correct because we wouldn't want to get any of those values wrong, or we're going to get different or the wrong answer. So now, determine and graph the equation of the least squares line. Well, the first thing I'm going to do is I'm actually going to plot that data and see what it looks like. So having clicked that button, did you notice which button I clicked? It was this one here, which is effectively a shortcut to the set graph. I have 9 different graphs I can use here. So I stay in the first one. I'm going to click on, and I want a scatter plot. All right, we'll do a scatter plot. My X list, what's going to go on the bottom? Well, in this situation, they're telling me height has to go on the bottom. So when I scroll down here, I go height, which would suggest that on this one, I would have to do weight, hit set, and nothing's happened because we now have to tell the calculator, well, can you draw that graph for me? And piff, paf, poof, there we go. There is my beautiful graph. So we've done that. I now need to fit my least squares line on. How do we do that? Well, we're going to go back to my list to make sure you're on this list with this blue square around it. And we notice it now says calc, regression, and I want to do a linear regression. Now, again, the calculator is not clever enough to remember what you've decided is on X and Y. You may mix things up, who knows why. But we're now going to say our X list is going to be, what did we say, height, and our Y list is going to be weight. Leave the rest as it is for this time being. Click on OK, and up come my values of A and B. And as it turns out, this was the actual data. Whoa, Cambridge, you tricked us. And what do we notice here? Well, we have my A value, as minus 84.8, which when we round it to, oh, this case, it's being interesting because it wants it to 3 significant figures. Be very careful to always make sure you write these things in the way that it is asking you to do it. Okay, so A minus 84.8, and my value of B in this situation is going to be 0.867. All right, so there's my A and B. Now, actually, the question went on and said, well, graph this thing. Interestingly, when I hit OK, piff, puff, poof, out comes that graph. Now, in a later video, I'm going to show you that you can get your graph to show you your equation of the least squares by hitting this button here, this XY button, and out comes that. Now, this is fraught with danger, all right? And I would use clicking that button with reservation, because if you make a silly mistake or you write down that equation with y equals, you're in all sorts of trouble. Now, what I'm trying to say here is your least squares line has to have the variables of height or weight on it. And if you just copy down what is written here, then you are in all sorts of trouble, because you're not going to write weight equals, you're going to write y equals. So just use that with reservation. All right, so what does it say? It says determine and graph the equation of the least squares regression line that will be able to predict weight to be predicted from height. Okay, so I'm now going to write weight is equal to minus 84.8 plus 0.867, and we're going to times that by height. Pretty much we're done. Now, sometimes they will ask you to, and we're going to do that example in a moment, they'll ask you to actually interpret the slope, or they'll ask you to interpret the intercept, but let's not rush ahead with that. So there we go. That's literally all you need to do. Now, if you're a TI Inspire user, I'm so sorry, guys. I used to love the TI Inspire, but Casio have it for me for the time being. I will release videos much, much later on where I do the TI Inspire, but pretty much you should be able to sort of extrapolate the information. Okay, and because I taught this to a group of students here in Australia in my own classroom, these are the type of things I say, well, stick it into your summary book. Later lessons that I do, or my PDFs, will have screenshots of calculators very much like this from the Cambridge book, but hopefully a lot more screenshots and a little bit more detailed. So how does this help us with anything? Well, ladies and gentlemen, we have VCAR exam questions. And the more of these you do, and the more of them you practice, and you see the tips and tricks that they are throwing in there, the better you will be as a student. So, question number 3 from the 2016 Paper 2 paper basically gave you some data that said apparent temperature, actual temperature, and the great thing is they gave you the graph as well. So we knew what the explanatory variable was, and we knew what the response variable was, and we can see that this graph is beautifully sloping up. There seems to be a straight line on it. We knew there was 13 data items. And probably one of the most interesting pieces of information there is the value of r squared. All right, so I'm going to write that again here. R squared is equal to 0.97. Awesome. So we've got that data there. I'm going to actually just minimize my calculator for a short while. And we're going to look at the first part of the question. Is use the scatter plot to determine the association between apparent temperature and actual temperature in terms of strength, direction, and form. Now, actually, interestingly, this value of r squared here is probably the most important to me, because from that I can work out my value of r, my Pearson's correlation coefficient. Because if I know what my Pearson's correlation coefficient is, I can use this funky little table here, and that's going to help me work out at least all of that information, or 2 of them. So I'm going to bring up my calculator because they've given me the value of r squared. Let's go back into main, if you will, and let's bring up my keyboard, because I now want to do the square root of 0.97. That's how you undo. Let's just delete that and put 97 and then hit enter, and we get 0.984, so 0.98. So let's write 0.98 here. What do I do now? Well, ultimately, just look up where does that value fit on my table, my reference table, which should be in your summary book. And there we go. We have a strong positive association. Now, is that giving me all the information I need? Sadly not, because I need to do strength, direction, and form. Now, when it says form, it's either linear or non-linear. So in this situation, we would be writing our answer as strong, positive, and linear. And believe it or not, that's what we needed for those 1 marks. And the question goes on, and it says determine the equation of the least squares line that can be used to predict the apparent temperature from the actual temperature. Okay, so it wants you to now do the analysis, which means you've got to enter all that data into your calculator. Well, Good news, I've already entered that data into my calculator and I've made sure that it is correct. What do I do now? Well, I'm going to scroll up for just a little bit because it says determine the equation of the least squares. Now, I don't actually have to plot the scatter plot. All I can do now is go calc, regression, linear regression, and make sure that I get these the right way around. Now, obviously on my X is my actual temperature and on my Y is my apparent temperature. I want to click on OK. Outcome, those values there. So my A value is minus 1.65, but we've got to be very careful, guys, because the question says answers must be rounded to two significant figures. All right, so that gives me an A of minus 1.7 and my B value at 0.940.94. And there we go, that's that question answered. I'm going to hit OK on my calculator. And as it turns out, it plots that graph for me. Thank you very much. And yes, that does seem to fit between those little kisses. So life is good. Now it goes on to say, interpret the least squares line in terms of the variables apparent temperature and actual temperature. So interpret the intercept. Okay, so what that would suggest that, now what does that minus 1.7 mean? It means when my actual temperature is 0 degrees centigrade. Now, again, don't get tricked. This starts at 20, but our intercept is when it is 0. So our actual temperature. So let's see what we can write. When my actual temperature is 0 degrees C, my apparent temperature is, is minus 1.7 degrees C. There we go, I've interpreted it. You've got to be very, very careful there. The coefficient of determination for the association between the variables apparent temperature and actual temperature is 0.97. Interpret the coefficient of determination in terms of these variables, and again, another worded question. What does that actually ask me to do? Well, if we know that it's 0.97, we multiply that by 100 to give me 97%. So we know that 97% of the variation in apparent temperature can be explained. I always get that wrong. Explained by the variation. Oh, my handwriting today is terrible. In actual temperature. Now, believe it or not, there are boilerplate responses for these type of things, right? So 97% of the variation in the response variable can be explained by the variation in the explanatory variable, and you just pretty much write those. And again, here we go, VCAR paper 2, the number of male moths caught in the trap set in a forecast and the egg density in the forest are shown in the table below. Okay, determine the equation of the least squares regression line. Whoa, it happens a lot, doesn't it? Well, yes, there's probably always going to be one of these questions in there, and a data transformer as well. So, and having pre-populated my data already, there I've got my num to stand for my number of male moths. Now obviously we have to be careful, there are certain words that are keywords here and I couldn't call it number, I couldn't label my list as number, and the calculator will tell you if there are any words you can't use. So I use num, and obviously the next column is called density. Yay! Determine the equation of the least squares line. I don't need to graph this thing because I'm just going to go calc, regression, linear regression. Okay, what is on the bottom? Well, we can tell from this equation here, they've already filled it in. Oh, let's actually use a highlighter there. We've already filled it in with egg density and number of male moths. Which one is my response variable and which one's my explanatory? Here is my explanatory, the number of male moths. So my X list would have to be number and my Y list would have to be density. Click on OK, and there we go, up comes my information. So let's delete this if you would be so kind. Bring on my pen. And so my value of A, what does it want it rounded to one decimal place in this situation? Minus 46.8, and multiply that by my value of B, which would be 18.9. So make sure you round to the correct order of magnitude. The number of female moths caught in a trap is set in a forest, and the egg density in the forest was examined. The scatter plot of the data is shown below, and they've given you the equation here. And it says draw the graph of this least squares line on the scatter plot on page 6. Okay, so you had to draw it on page 6. I don't have that for this moment in time because I haven't copied it in. Okay, but it's not going to actually stop me from getting on. So I'll leave that to you to actually sketch it. And that's for my previous example. And so let's now go and see what's the next part of the question. Interpret the slope of the regression line in terms of the variables egg density and number. Now in the slope in this situation, what they're saying is, so you would say for each increase by 1 of the number of female moths, egg density increases by 31.3. Okay, so that's the important thing here. Yes, what we're saying is for each 1 increase in the female moths, we are going to go up by 31.3 for egg density. There we go. The egg density is 1500 when the number of female moths caught is 55. Determine the residual value of the least squares line is used to predict. Now the residual, if you remember, is equal to the actual minus the predicted. Okay, so let me see. The egg density is 1500. So the actual value is 1500. I need to work out what my predicted value is. How am I going to do that? Well, just bang it into this here, all right? So they're saying the number of female moths is 55. Let's bring up my CAS. Let's go into my main screen, and we are going to do 191. We're going to add that to 31.3. 3 multiplied by 55, which gives me 1912.5. So 1912.5, 1912.5, and so we are going to subtract those. So 1500, no, not 1501, 1500 minus my previous value. Let's just drag and drop and hit enter. Gives me minus 412.5. So minus 412.5 is my answer. And does it say determine the residual value, blah, 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 blah. So there we go. So it's just minus 412.5. The correlation coefficient is 0.862. Determine the percentage of the variation in egg density. Now, the minute I see the word variation, I know that it's asking me to look for the value of r squared. They've given me the value of r, so I'm going to have to take the value of r and square it to give me my value of r squared. So 0.862, and then we're going to square it. Hit enter. Gives me 0.743. So my value of r squared is 0.74, which we now know, let's minimize that again, which we now know will, got to be careful because the question said round it to 1 decimal place. So I'm going to multiply that by 100 to give me the percentage, which gives me 74.3. 74.3% rounded to 1 decimal place. Now, there we go. We have pretty much gone through how to use your calculator to find the values of A and B outside of that horrible formula all the way at the beginning of this question. Okay, so with any luck, ladies and gentlemen, you are now going to be guns at this particular work, because realistically speaking, all the work in the next few videos is just going to repeat this, but we're going to actually have to write about it. So the whole point of further maths is taking your data, doing something with it, and then interpreting it, writing about it, which you can all do because there is also boilerplate code. Your summary book is going to actually be your savior here. All right, I'm done. Thank you so much for watching. If you haven't already done so, can you subscribe by clicking the doohickey and let people out there know these videos are there. It has been a joy and a pleasure seeing you. I will see you a little bit later on for another video that will drop with regards to this content. Have a good day. I'll see you next time. Bye-bye.